Good morning, everyone. Today is Monday, January 30th, and this Friday we have homework 2. So homework 2 covers P.5, 1.1, and 2.1. Right, everybody? So I haven't graded your homework 1 yet. I'm gonna grade it today or tomorrow. Okay. So usually I don't work over the weekend because the kids are at home. I need to send them to like activities, like do the cooking, and I'm busy with them. So yeah. All right. And this is the 1.3 handouts. So yeah, please grab a copy. And I still have 2 copies of 1.1, 1.2, and 2.1. Oh, do you need a copy of the new handouts?
Thank you.
You're welcome. All right, so let's look at our last worksheets. We still have one problem that we haven't finished. Okay, so last time we talked about slope, and we talked about the slope-intercept form and the point-slope form. Do you still remember? Yes? Yes? Mm-hmm. I hope so. Okay, what is the slope-intercept form? Y equals ms plus b, right? How about point-slope form? Don't get it. Don't get it. Point-slope form. Y minus y1 equals x m. So times x minus x1. Right? Point-slope form. Last time we did example 1, right? We know the slope was 3 and we know the point is 1 comma negative 4. So y minus the y coordinate of the point equals the slope times x minus the x coordinate of the point. Right, everybody? And point slope form is not unique because if you give me another point on the line, I can could use that the new points to get a different form. But if you solve for y and get the slope intercept form, this is unique. So in the exam, make sure you express your final answer in the slope intercept form. Is that clear, everybody? So if this problem has 5 points, and then maybe here this step is 2 points, and then here's 3.4, and then this is 5 points. Okay, so if you only write down the partial form, maybe you only get 2 or 3 points. So please express your answer in the slope intercept form, because that is the form is unique. Okay. And then if we are given 2 points, we first find the slope. Right? Slope is change of y over change of x. Okay, and make sure the order match. If you're using the second point, y coordinate minus the first point, y coordinate, and then downstairs, second point, x coordinate minus the first point, x coordinate. Make sure the order match. Okay, and that is the slope. Then you pick one of the points. Which point doesn't matter. You end up getting the same slope intercept form. Okay, everybody? Yeah. All right. So last time we also learned that if 2 lines are parallel, what happens to the slope? Same. If 2 lines are perpendicular, opposite reciprocal. Yeah, opposite reciprocal. You flip the numerator and denominator. Okay, everybody? Mm-hmm. So now let's look at example 3. Find the equation of the line passing through the point 3 comma negative 5 and is perpendicular to the line whose equation is negative 3x plus y equals 1. Express the equation in both point slope form and slope intercept form. Okay, so actually let's do both. Okay, so here the problem says we want to find the line perpendicular to it. Let's find both. Find a line perpendicular to it and find another line that is parallel to it. So yeah, let's put a mark here. Okay. All right, let's say we want to find the equation of a line, let's call it line 2, that passing through the point. So line 2 passing through this point, 3 comma negative 5. And line 2 is perpendicular to the line. Let's say this line is line 1. And this is the equation of the line 1. So we have 2 lines here. They are perpendicular, right? Okay, so line 1, the equation is negative 3x plus y equals 1. And we want to find the slope. Okay, so how do we find the slope? How do you get slope into the form? We solve for y, exactly. We add 3x. Very good. So we add 3x on both sides. Then we have y equals 3x plus 1. Right? What is the slope? 3. Right, everybody? Don't say 3x. X is a variable. Slope is the number, the constant is the coefficient of x in the slope intercept form. Okay, so slope M1. Okay, M1 is the slope of the line 1. M1 is 3. And then we know line 2 is perpendicular to line 1. Have you seen this symbol before? Yeah, it means perpendicular. Okay. Then, oops. Then we know M1 times M2 is negative 1. So M2 is negative 1 over M1. Negative reciprocal. What's the reciprocal of 3? Yeah, negative 1/3. So this is the slope of line 2. Okay? Great. We know the slope. And we know a point on that line. Right? Poisson form. What's that? Y minus. Yeah, y minus what? Y minus. What's the y coordinate of the point? Yes. Equals m. Yeah, m is negative 1/3. X minus 3. Yes. Okay, let's see. Y minus minus become plus. Let's distribute. Negative 1/3 x. What's negative 1/3 times negative 3? 1. Right, everybody? Okay, so we want to solve for y. Yeah, we want to get slope-intercept form. So we subtract 5. So y equals negative 1/3 x minus 4. Right, everybody? Yes. So in the exam, your slope maybe more complicated, and then you have fractions. So you're gonna work with fractions. Okay. So in your answer, if I don't say express your answer in 3 decimal places, then I assume you use fraction. Especially these kind of problems, okay? We want exact answers. Please use fractions. In your homework, I suggest you not to use your calculator. After you finish, you can use your calculator to check the work. But when you're doing your homework, try not to use your calculator. Okay? And in the exams, I allow you to use your scientific calculator. Okay? So, but still, try to calculate it without a calculator and then use your calculator to check. And make sure you know how to use your calculator and get fractions. Okay, clear? Yeah, fractions. So usually only the application problems, which we're going to talk about in this 1.3, we could use decimal numbers. Okay? And then other problems, like more theory problems, we use exact answer. Attendance, yes. Okay. Wow, this is the 3rd week so quickly, right? Okay. Here. Now, how about instead of perpendicular, How about if our line 2 is parallel? So if line 2 is parallel to line 1, what do we do? Well, this step is the same, right? We still have line 1, we want to find the slope. But now line 2 is parallel to line 1. Okay, so sometimes we use this symbol parallel to line 1. Have you seen this symbol before? Yeah. Okay, then so M2, so instead of that, M2 will be the same as M1, right? If they're parallel, the slope are the same. Then that equals 3. Right, everybody? And then, oh, we have the slope. We have the points. Then we can use point slope form. So y minus what? y1, which is -5, equals slope 3. And then x minus 3. Yes. Okay, y minus negative become plus. And then we distribute. 3 times x is 3x. 3 times -3 is -9. And then we subtract 5 on both sides. So y equals 3x minus, woo, yes. Okay. So for this problem, this is the solution. And I'm saying that if instead of perpendicular, we have line 2 is parallel to line 1, this is the solution. Okay? In the exam, you will have both problems. Okay? Yeah. All right. So that's it for linear equations. Any questions about this worksheets? All good? Okay. So now let's look at 1.3, modeling with linear equations. All right. So our course, applied algebra. We learn the theory about algebra, and then we learn applications. Okay. So first, solving linear equations. Solve the following equations. There are many different ways to solve equations. Okay? You might have learned that before, and your teacher might use maybe different ways than I do. That's okay. Just make sure you show all the steps, and if you get the same final answer, then you're correct. Okay, everybody? If you get different answers, come to see me. Okay, maybe you have made mistake, or maybe that method is not applicable in that situation. Right. Okay, so let's see. Okay, so we want to solve for the following equations. First of all, we want to break the parentheses. So we distribute, right? 6 times x is 6x, right? 6 times -1, -6. Plus 4, 3 times 7, 21x. Plus 3, yes. Okay, and then let's combine the like terms, right? So 6x minus 6 plus 4, what's that? -2. Okay, we want to solve for x. So we want to move all the x on one side, and then the constant term, keep it on the other side, right? Okay, questions. What do we do here? What operation shall we do? Subtract 6x. We don't subtract 21x. Why? Yeah, that would give us a negative coefficient. We want a coefficient to be positive. Just keep things safe. For equations, it doesn't matter whether your coefficient is positive or negative. But for inequality, you gotta be more careful. Because when you multiply or divide it by a constant number, you won't change the inequality. But when you divide it by or multiply by a negative number, it will flip the inequality. Okay, so if students forget to put the inequality, okay, that's a mistake. So to avoid making those kind of mistakes, we try to find a way that is faster and less chance to make mistakes. So we subtract 6x. Okay, here, negative 2. 21 minus 6, what's that? 15, yeah, 15x plus 3. Okay, what do we do next? Subtract 3. Okay, what's the left-hand side? Negative 5 equals 15x. What's x? We divide it by 15, then negative 1/3. Yes. So this is the answer. Right, everybody? All right. What happens if we have a fraction? Well, we want to find the common denominator, right? What is the least common denominator here? 12. Yes. Okay. So what do you usually do? Do you multiply by 12 on both sides, or you want to make each term has 12 at the bottom first? Each term has 12 at the bottom first? Okay. So first term, what do we multiply? 4. Okay. And second term, what do we multiply? 3. Okay, right hand side, what do we multiply? 12. So make all the terms have the common denominator, right? Same denominator. All right. Then, oh, this is 4x over 12. Okay. Yeah, so usually x times 4, we like to put the coefficient in front of the x, right? So do it as 4x. And then this is what? 9x over 12. And that is 24 over 12. Now we can multiply both sides by 12. So when you multiply by 12, let's say we multiply by 12 here, we multiply by 12 here. Actually, you have a parenthesis, right? So which means you multiply each term by 12. Okay? So this multiplied by 12, you get 4x. And second term, 9x, right? Equals 24. What's 4x plus 9x? 13x equals 24. Then x is, yeah, 24 over 13. Right? Just leave your answer like that. Don't need to get decimals. You only get decimals is when you have a word problem. When you come to the last decimal. Okay? Usually get exact answer. All right. So that is part B. We increase difficulties. Do you see part B? Our least common denominator is just a number. Right, everybody? But part C. Do you see the denominator? We have variables in it. So when we have questions. Oh, we multiply both sides by 12. So we first of all figure out the least common denominator is 12. Then we make each term have the denominator 12. That's why the 2 we multiply by 12 and divide by 12. Okay? And then here we just multiply the 3 and 3, we get 9x. So this is 24 over 12. All the terms have denominator 12. So the next step, when you multiply both sides by 12, it's like, okay, I just hide all the denominator. Then you have 4x plus 9x equals 24. So it's kind of, we hide all the denominator. We multiply both sides by 12. Okay. Yeah. You're welcome. Okay, so part C. The denominator has fractions. What do we do? First of all, is you can factor. Linear term, this is the easiest one. You cannot factorize. But you see this is a quadratic term, right? How can we factor it? Yes, this is x plus 2 and x minus 2. Right, everybody? So what is the least common denominator? We collect all the denominator, right? So which is x plus 2 and x minus 2. Right, everybody? We collect all the denominator. Okay. Now, the least common denominator is, instead of numbers, we have x variables. Okay? Remember? Denominator. Our denominator cannot be 0. If the denominator is 0, then that term is not defined. Right? Everybody? So, when you work with rational expressions, after you find the least common denominator, make sure set it not equal to 0, because we want to find the domain. Okay, so x plus 2 times x minus 2 not equal to 0. That means both factor cannot be 0. Okay, so when you work with rational expressions, you must look at the domain. Okay, so rational expressions need the denominator not equal to 0. We gotta check that. So, and then here we add, subtract 2 on both sides. We get x not equal to negative 2. And then here we add 2 on both sides. We get x not equal to 2. So this is the domain. Okay. Domain is the possible x value, so that's the rational expression makes sense. Okay, everybody? And then, okay, now we can start to solve. It's very important to find the domain, because eventually, if you get the solution, maybe let's say you have multiple solutions. If one of the solution is this point, then those numbers cannot be the solution. Then you have to rule out those solutions. Okay, everybody? Any questions so far? Okay, so similar to what we have done, we make each term have this least common denominator. So look at the first term. What do we multiply by? What do we need? Yeah, x plus 2. Okay. And then equals to, on the right hand side, the first term, 3 over x plus 2. What do we multiply by? X minus 2. Okay. And the last term. Oh, do you see the last term? We already have x plus 2, x minus 2, so we don't need to do anything. Yes, everybody? Now we check. Each term has this least common denominator. So we multiply by the least common denominator on both sides. Right, everybody? So it's like, oh, okay, I didn't hide all the denominator. What is the numerator? So, yeah, x plus 2 equals, yeah, let's distribute in the next step, okay? So this is what we get after we multiply both sides by the least common denominator. And another reason why you want to do that is you multiply this on both sides. You want to make sure this number is not 0. Okay? Otherwise, if you multiply both sides by 0, you just get 0 equals 0. That gives us nothing. Right? Okay, let's keep going. X plus 2. 3 times x is 3x. 3 times negative 2.
-6 and -6x. Okay, let's combine the like terms. What's 3x minus 6x? -3x, right?
Okay, what do we do? Add 3x, right, everybody?
We add 3x on both sides. And on the left hand side, we get 4x plus 2. And then, yeah, what do we do next? Subtract 2. Then we have 4x equals -8. What's x? -2. Oh, no, what happened?
What happened? It's outside of the domain. Okay, therefore, no solution.
Okay, so no solution.
Yes, we find number, but this is outside of our domain. X cannot be -2, therefore, no solution.
I did that.
Oh, because that's the denominator. That's why. So this part, okay, this part is like solving it. But you need to think about, okay, what values of x such that this expression makes sense. So if you see rational numbers such as like x plus 3 and 2x minus 7, something like this, what do you need? In order to have this rational expression make sense, you need the denominator is not 0. So you need the denominator is not 0. And if we have like 2x minus 7 equals 11x plus 5, something like this, your equations involve square roots. Whenever you see square roots, you need the 2x minus 7 to be greater or equal to 0. You need the things inside the square root to be greater or equal to 0. So that's why when you see in your equations, if you see rational expressions or square roots, you gotta be careful because x, the domain of x is not all real numbers. So you have to find the domain first. Okay? Yes. The denominator cannot be 0. That's why we rule out those cases. Okay? And you get a final answer. If it's in here, then those numbers are not from the domain. So therefore, no solution for this equation. Okay, everybody? Yes. That's why when you solve equations involving rational expressions or radical expressions, at the end you need to check your work. You check your work, check whether your answer is in the domain. If yes, this is the solution. If not, then this is not the solution. Okay, everybody? So in section 1.4, which is just right after this session, we will solve more types of equations. Okay, then I will summarize the steps and then we'll follow the steps.
Okay, let's keep going. Translating keywords and phrases. So keywords and phrases.
This is a verbal description example, and this is the algebraic expressions or equations. Equality equals to is are was will be represents. Example: the sale price as is $10 less than the list price. Okay, is the keyword. That means equal. So the sale price as equals what? $10 less than the list price. So it's out minus 10. Right, everybody? $10 less. So subtract 10. Addition. Sum plus increase by more than a total of the sum of 5 and x, 5 plus x, right? 7 more than y, so y plus 7 or 7 plus 5, okay? For addition, order does not matter. But for subtraction, you gotta be careful. The difference, minus, less than, decrease by, subtract from, reduce by. The difference of 4 and b. 4 must come first. If 4 minus b and b minus 4, they're different things. So you gotta be careful. Okay, everybody? 3 less than z. 3 less than z. So you start with z. 3 less than, subtract 3. Okay, everybody? The typical mistake. This is z minus 3, not 3 minus z. We have international students here. So be careful. 3 less than z, even if the 3 might come first. But because of this phrase, it means z minus 3. Okay. Yeah.
And then multiplication.
Products multiplied by twice times percent of 2 times z. That's x. So 2 times x. 3% of t. 3%. 3% times t. And you also know that 3% is 0.03. Right, everybody? It's not 0.3. 0.3 is 30%. Okay. Division. Portion divided by ratio. For the ratio of x to 8, we put the x on top. 8 to 8. Okay, everybody?
All right, example. You accept a job
With annual income of $32,300. This includes your salary and a year-end bonus of $500. You are paid twice a month. What is your gross pay before taxes for each paycheck? Okay.
So first of all, let's okay. What do we want to know? We want to find the gross pay for each paycheck. So let x be the gross pay for each paycheck. Okay, so set x be that variable.
And then we pay twice a month. How many months in a year? 12. So how many times do you get paid?
24, exactly. So therefore we get 12 times 2 times x. Yeah, that is 24. This is we pay twice a month, okay? And
Plus, so this annual income includes our salary. So this is our salary. And a bonus of 500.
so this part is our salary plus our bonus is 500. That equals the total annual income. Okay, that's the income. Yes.
I thought the 500 are included.
Yeah, it's included. That's why when you count this, you're using this, subtract 500. Yeah, it's the same thing. If you don't like to do it that way, you can do 32,300 subtract 500 and then divide by 24. See? Yeah, it's the same. Okay.
Exactly. So we solve for x. Therefore, 24x equal plus 500 plus 500 equals 32300. Subtract 500 on both sides. We get 24x equals what's 32300 minus 500? 31. Thank you. And then x is both sides divided by 24. And what do you get? 1325. Thank you. Okay. Yes. So when you order applications problems, yes, you can use your calculator because usually the number are harder. So this is your paycheck. Yeah, every time. Any questions about example 2? Okay, all good. Example 3, your family has an annual income of 557,000 and the following monthly expenses: mortgage 1,100, car payment 375, food 295, utilities 240, and credit card 220. The total value of the monthly expenses represents what percent of your family's annual income? Okay. What is the monthly expenses? So we first figure that out. Yeah, by the way, it depends on your need. You don't have to set the variable x. In this problem, yeah, like 46, you can subtract 500 and divide it by 12, but like 0 by 24, then you get the answer. Then you don't have to set the variable x. Usually, if the problem get more and more complicated, then we set the variable. Okay, everybody? And then this problem, we don't need to set variables because it's quite straightforward, right? We calculate the monthly expenses. That includes mortgage, 1,100, and then 375, 295, 240, 220. Okay, use your calculator. Add those numbers together. What do you get? Yeah, everybody take out your calculator. Okay. So I hope all of you bring your calculator because I do have students ask me in the exam how to use the calculator. In the exam I cannot answer those questions. So please practice using your calculator. Yes. In the exam, I can only answer questions about the question. So if you don't understand the question, I can explain more so that you can understand. But I'm not able to teach you how to do it and check whether you're right or wrong in the exam. Right? So the questions. So what number did you get? 2,231? 30. Oh, thank you. Okay, so that is the monthly expense. How about the annual expense? Okay, annual expense. How many months in a year? 12. So if you multiply by 12, what do you get? Thank you. Okay, now we want to find the total value of the monthly expense. What percentage of our family annual income? The percentage, we're using the total expense divided by the income, right, everybody? And sometimes if you get confused, oh, which is on top, which is the bottom, you usually put the smaller number on top and then the bigger number is at the bottom, right, everybody? Yeah. Okay, so percentage 26760 divided by 57,000. And what do you get? Give me 4 decimal places.
0.4684.
Thank you. Right, everybody? Is it A4 or 94? It's 9? Okay, yeah. And we want to make it percentage. So percentage means we multiply by 100%. So you move this decimal point 2 digits. You get 46.94%. Is that okay, everybody? Mm-hmm. Yes. All right. Keep going. Example 4.
A rectangular kitchen is twice as long as it's wide. Okay? And its perimeter is 84 feet. Find the dimensions of the kitchen.
So here, some basic shape you gotta know, like square, rectangle, circle, triangle, parallelogram. Right? yes. So here, rectangle. Okay, for rectangle, the dimension, we have length and width. So set the variables, length and width.
Okay, everybody? Then look at each sentence. A rectangular kitchen is twice as long as its wide. What does that mean? L equals width times
2, exactly. So length is 2 times width. Right, everybody? Okay. And then next sentence.
its perimeter is 84 feet. What's perimeter? Yes. So this is L plus W plus L plus W.
So perimeter is 2L plus 2W equals 84.
Right, everybody? This is an equation with two variables. Okay? Then there must be a way we can eliminate one of the variables, which is here. Do you see 2 with, okay, 2 times W equals L. So you can replace 2W by L. Then you get the equation of L only. Then you can solve for L. Or you can plug in the L. So L is 2W. So then you get 2 times 2W. You get an equation about W only. Then you can solve for W. Okay? So whenever you see equation with two variables, there must be other relations so that you can eliminate one of the variables. So that you only get an equation of one variable. Which way you think is easier? Plug in the L equals 2W or replace the 2W by L? Plug in the 2W for L.
Yeah, so these two ways both works. So up to you which way you prefer. So 2 times L is 2W. 2 times 2 is 4W. 4W plus 2W is, so this is 4, plus 2 is 6W is 84. What's W? What? 14. Thank you. Oh, W is 14. What's L? 20, 24? 28. Yes, good. So the dimension is 28 by 14 feet. Okay.
So the unit is feet. So far, so good, everybody?
Okay. How about I ask you a different problem here. How about I ask you if the area is 50 feet square feet, then what do you do?
Okay, so in the given the perimeter, let's say we're given the square. And what do?
Area. Area is length times width, right? So length times width is 50. Now we replace length with 2W. Then you get 2W squared is 50. What do you do? divided by 2. W squared equals 25. What's W? 5. Good. And usually when you take square roots, you get plus or minus square roots. So you get two answers. But because we're working with application problems, we only pick the positive one. Okay. Then your length is what? 10. Exactly. So dimension is 10 by 5 feet. Okay, so this is another problem. Instead of giving you the perimeter, it gives you this area. Okay, everybody? Good. Let's continue. Any questions about the example so far? Are we all good? Okay. Let's see. Okay. Okay. So a plane is flying nonstop from Portland, Oregon to Atlanta, Georgia. A distance about 2,170 miles. After 3 hours in the air, the plane flies over Topeka, Kansas, a distance of about 1,440 miles from Portland. Assuming the plane flies at constant speed, how long will the entire trip take? Okay, so in this case, we gotta draw a picture. So, draw a picture. So, Portland and to Atlanta. And the distance is 2170. Okay, and here, this is Topeka. This distance is 1440. Right, everybody? And this is 3 hours. So it takes 3 hours. Have you learned physics before? You know speed is distance over time. Do you know that? Right? Okay, now here, you see, from Portland to Topeka, the distance is 1,440 miles. And the time is 3 hours. So we can use this to find the speed. Okay? Right, everybody? And because it's constant speed. So the speed here is the same as the speed everywhere. Right? It's constant speed. So therefore we get speed distance is 1440. Time 3 hours. Okay, plug into your calculator. What do you get? $480, right? This is miles per hour. Okay, our goal. How long will the entire trip take? Now we know the speed. We know the distance. Can we find the time? So time is distance over speed. What is distance? Yeah, what is speed? Yeah, what do you get? Give me 3 decimal places. Oh, 4.520 and miles per, hours, right? This is time. Time is hours. Okay. By the way, when you round the numbers, if the next digit is less than or equal to 4, we just round up. If the next digit is greater or equal to 5, we round up. Right, everybody? Yeah, so application problems, yeah, keep 3 decimal places, or if this is the exact number, keep it like this. So we'll continue on Wednesday. Okay. Have a nice day. Yeah, start doing your homework too. And if you have questions, feel free to let me know.